Hello and welcome to the third practice problem in the Programming in Python 3 course. The topics covered in this practice problem are for and while loops, operators, and user input. If you're new to these practice problems, essentially how they work is in the first part of the video, I'm going to read through the problems, and then in the second part of the video, I'm going to show you my solution to this. My solution is completely unedited and it is authentic. I have not prepared any solutions to these, so you will get to see my live thought process. I highly encourage that you pause the video before you see my solution so that you can also think about how to solve these and really gain some problem solving skills which you can use in the future. So with that being said, let's go ahead and get into the practice problems. In part A, we are going to implement a common developer interview question called FizzBuzz. FizzBuzz is a very common beginner developer interview question. And essentially what you do is that for every number from 1 to 100, you output the number. If the number is a multiple of 3, then you output fizz. If the number is a multiple of 5, you output buzz. And if the number is both a multiple of 3 and 5, then you output FizzBuzz. So an example output here is 1, 2, fizz, 4, buzz, few numbers, 14, FizzBuzz, and so on and so forth. The bonus for this problem is whichever loop you used in the original problem, use the other type of loop. Also, try and rewrite it as creatively as you can because believe me, there are a lot of ways to write FizzBuzz. It's actually kind of a joke on the internet to see how creative and crazy you can write FizzBuzz in whatever language you're writing it in. In part B, we're going to implement a very basic number guessing game. Problem says to write a program where the user tries to guess which number the computer picks, you being the user. The program should count how many guesses the user's made and should let the player know if their guess is too high or too low. To go ahead and give you the code to allow the computer to make a choice, you can go ahead and type in this code snippet that I've provided, but don't worry, we will talk about this specific code snippet in a future video when we talk about modules. The bonus for this problem is to add some complexity to the player. Allow the player to only guess a certain amount of times, for example, 10. If the player doesn't guess within those bounds, then I'll put a message letting them know they lost. Like I mentioned before, I highly recommend that you pause the video right now, go back, reread through those problems, and attempt them on your own before you watch me solve them. I also want to reiterate that I don't have any solution to these on my other screen or anything, so I'm writing this from scratch, but I will warn you I have written FizzBuzz a few times, so I guess you can consider that cheating. But with that being said, let's go ahead and get into it. Great, so for part A, we are writing FizzBuzz. So this problem says to do from 1 to 100. So initially when I see 1 to 100, I think that I want to use a for loop because I can just use the range and it will return an iterable from 1 to, or whatever number to 100. So 1 to 100 here. So I'm going to do for I in range 1 to 101, and the reason why I'm doing 101 is that because range is exclusive. So if I did 1 to 100, then it would actually be 1 to 99. So I have to do 1 to 101, and pass here just means to kind of ignore the block temporarily. So here's where we're going to do our real computation. So the first thing says that if it is a multiple of 3, then you print fizz. So initially, I'm going to do a check on I. I'm going to say if I, and actually mod 3, because if you remember when you talk about modulus, that's how you get the remainder of something. So you know if the remainder is 0, then that means it has to be a multiple of something. So if I mod 3 equals 0, then I'm going to print fizz. And then initially, if you were a little stumped, maybe now you can kind of see where we're going here. Then I will do if, I'll do elif, sorry, not if, elif I mod 5 is equal to 0. Then I will print buzz. And then I will also do elif I mod 3 equal, that's 4, 3 equals 0, and I mod 5 equals 0, then I'll just print fizz buzz. Oops. And then in all other cases with an else here, I'm just going to print I. And if we go ahead and give that a run, let's go ahead and see what happens. So if we scroll up a little bit, we should get 1, 2, fizz, 4, buzz, fizz, 5 is a multiple of 5, 6 is fizz, and let's go to 15. Oh, so initially you can see that actually it printed fizz, not fizz buzz, and that is because I made a silly mistake. You need to do the most specific test first. So we talked about this earlier. Whenever you're doing if statements, you actually want to make it the most specific first so you can kind of narrow out the conditions. So I know that actually here, if it equals both of them, then I can print fizz buzz. And I will change this to if and indent that, and then I will actually just change these to elif and elif, and then else I'm still going to print I, and then this should actually fix our problem. So let's see here. Yep. Looks good to me. Yep. Okay. So apparently I haven't written it enough. Yeah. So in general, the key takeaway here is that you just want to make sure that whenever you're doing any if checks, you always do the more specific one first to narrow down your choices. That's a pretty good rule to keep in mind whenever you're writing any sort of software or code or scripts or whatever. So if we go ahead and take a look back at the bonus, and I'll go close this, the bonus says essentially whichever loop you used, use the other type of loop. Okay, great. So I used a for loop in this case. If you used a while loop, then you would use a for loop. I'm going to use a while loop. So I will go ahead and comment all of this out for reference, and now I have to keep a few things in mind for a while loop. So first I need to keep a, the initial counter. So I'll do I equals 1, and I'll actually do while I is less than or equal to 100. So that's already one of the benefits of having a while loop, is I can kind of make that check to see if it goes up to 100. So I don't have to do 101. So then I need to increment I at the very end before I even think about anything. And then essentially I just do the same checks that I did before. So if I mod 3 equals 0 and I mod 5 equals 0, then you're going to print fizz buzz. And then in the next case, if I mod 3 equals 0, print fizz. Then you do your I mod 5 equals 0. And then that would be print buzz. And then else you just print I. And give a space there. And if we run that, we should just get the exact same thing. So let's see, do our check at the beginning here. 1, 2 fizz, 4 buzz, fizz, 7, 8 fizz buzz, 11, yep, go to 15, fizz buzz, and then fizz buzz. Yeah, that looks great to me. Awesome. There is another method of doing fizz buzz, and it actually involves string concatenation. Now, whether or not I would recommend you do this, it really doesn't save any time or anything. It's still the same base loop. But one thing you might have noticed is that you are printing something at the end of each block. So if you have written code before, then that might already set off kind of a red flag in your head that, hey, every block here is printing something. So maybe I could just get rid of the print on the inside, and then I could just print whatever here, right? So here's how you do it. And I'm just going to keep with the while loop, but you can just completely do this the exact same way with the for loop, as long as you're inside the block. What you actually want to do is you want to set some sort of string, I'll just call this like S, right? And we want to set it to an empty string. And then essentially how this is going to work, and it is really, it's funny. I think it's kind of neat, to be honest. So we keep our same loop structure, but we actually are going to concatenate the message that we want, right? So we're going to concatenate fizz, and we don't even need both of them anymore, and you're going to see why, if I remember this correctly. You actually want these all to be ifs. And the reason you want them all to be ifs is because you want to concatenate something. So here, the else is going to do s plus equals, and we have to cast the number to a string because it is a string, right? And then what you do is if it is a multiple of 3, you do s plus equals fizz. If it's a multiple of 5, you do s plus equals buzz. And what this will do, actually, is it kind of eliminates the need to do an else if here. Or I should say, if we don't do an else if, then these ifs are always going to be checked, no matter what. So rather than having a check for if it's both a multiple of 3 and 5, then you can actually just do a check if it's a multiple of 3, if it's a multiple of 5, and then if it's not, you just concatenate the string. And then at the bottom here, we just print s, increment our counter, and let's go ahead and run it, and you'll see here, well, actually, yes. So basically the issue here is that I have an else block for here, so I'm still concatenating the number. So what you would actually want to do is you would want to have a check to see if the multiples, or if they're not multiples. And the reason is because, like I mentioned before, so you want to do a not equals, and that is because it's catching every number afterwards. So you only want that to happen if it's not a multiple of 3 or 5. So if we go ahead and copy this check here. So if it's not a multiple of 3 and it's not a multiple of 5, then you concatenate its string version, and there we go. Got to do a little bit of thinking there to realize kind of how that works, but yeah, it is a pretty neat, and it is very creative. So just kind of do a little bit of exploring and testing on your own and see how you can implement FizzBuzz, and see if you can be the next person on the internet to come up with the strangest and most Pythonic or creative way to implement FizzBuzz. So let's go ahead and do part B now. So part B, we are implementing a number guessing game. Awesome. So it is a little fun. You know, the idea is the computer makes a choice from a number in between 1 and 100, and then you, the user, have to guess what the number is. And we're going to have a little guess counter in here, and what we'll do is we'll just kind of see how many guesses it takes, right? So it already said that we can use this code snippet here, and this, all it does is it just lets the computer pick a random number in between 1 and 100. You can see rand range here, and essentially that's just like the range in a for loop, but it's a random range, so it just returns a number from that range. So here's our computer guess right here. Let's go ahead and get into this. So essentially, now we need to ask the user for their guess. So let's say user guess, and that will be the int of an input. Enter your number, or like what's your guess, and I need to escape that. Yeah, what's your guess? Or enter your guess, I guess. I don't know, I'm getting too specific here. Enter your guess, and then we actually want a while loop, because I don't know how many times this is going to take. And this one will be while the user guess does not equal the computer guess or the computer choice. And for now, I'll pass that. And we actually need to have a guesses variable to store how many guesses it takes. And then here's where we go. So the first thing is we actually want, similar to how we increment a a normal while loop, we actually want to give the user a chance to guess again. So initially we're going to do that at the very end of the loop, because then if that last guess is correct, then we want to actually increment guesses. And I'll make sure that I didn't put that in the wrong spot here in a sec, but that will let us know what our guesses were. So we actually want to do a guess and then increment again. So really what we want, I guess, is we want to start it off at 1 because the first guess is outside of the loop. So now we're going to say that you already by default start with 1. We want to say if the user guess is less than the computer choice. If that's the case, we just want to print you are too low. So that's if it's lower, right? And we don't need to do a check to see if it's less than or equal to, because if it's less than or equal to, then the loop wouldn't have executed in the first place, right? Here, it can only really be elif user guess is greater than computer choice. If that's the case, you are too high. And oops, I guess I'll keep that there. And let's just go ahead and run it and see what happens. So if I run this, enter my guess. I'll start with 50. I'm going to do some sort of binary search here. So 50 is too low. So then what's the next half? I guess I'll do 100. You're too high. Okay, so I know it's obviously in between 50 and 100. Do 75. Too low. Okay. Then I'll do 80. Too low. Let's do 90. Too high. So I know it's in between 80 and 90. So let's start with 85. Too high. Start with 81. Too low. So it has to be 82 through 84. Let's do 83. It's 83. It's got to be 82. And boom, 82. So what actually needs to happen at the end is you need to output great job. You won in, and I'm going to use an F string here, and I'm going to interpolate the guesses. So let's go ahead and try that one more time, and it will choose a different number this time. Same thing, let's start with 50. Okay, too low. Too high. Try that. Too low. Too low. Too high. Maybe it will be the same. It's not 82. It's too low. 85. Great job. I won in 7 guesses. Let's count how many guesses we got. Oops. Count how many guesses we got. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So I won in 7 guesses. So essentially, I'm just incrementing the guesses in the wrong spot, right? Let's try moving that up 1 line. Or actually, really what we want to do is that needs to go first. Well, hold on. That's our initial guess. That starts off at 1, 2, 3, 4, 5, 6, 7, 8. So it just did an increment in the right spot. Okay, interesting. Let's see. Start off at 1. Okay. Another thing that we could also try just to make it even easier is we can actually just immediately set the guess to 0. And the first thing that we will do is we will set the user guess to that input, and then we won't actually have to worry about doing that because then it will always check. So now let's go ahead and run it and see what happens. Run. Great. Okay. Let's enter my guess. 50 is too low. Try 80. 80 is too high, so I know it has to be in between 50 and 80. Let's try 70. Too low, so it's in between 70 and 80. Let's do 75. Too low. 79 is too high. So then it has to be either 74 through 78. Or sorry, not 74, 76 through 78. So we'll do 77. 77 is too high. It's got to be 76. 2, 3, 4, 5, 6, 7. So now I'm winning in 8 guesses. Why is that happening? Oh, right, because I need to set that to 0. I forgot to set it when I was doing the other one. Great, 50 is too high. 25 is too low. 40 is too low, so it's in between 40 and 50. 45 is too low. 47 is too low. Or sorry, 47 is too high, so we'll do 46. And I won in 6 guesses. 1, 2, 3, 4, 5, 6. Awesome. So there's the initial problem. Sometimes you just have to do a little bit of thinking in order to get the right solution. Obviously, the order here does matter. So, not all solutions going to look the same. This was my solution. Maybe you guys came up with something similar. I'm not sure. Let's take a look at what the bonus was. Add some complexity to the player. Allow the player to only guess a certain amount of time, so 10. Okay, so then I will add in essentially a thing that says you can only guess it in 10 guesses. So I will go ahead, and this is a pretty easy change. Guesses has to be less than 10. While the user does not equal the computer choice and guesses is less than 10. That's a simple line. If they do go, so now what we need to do is we need to have a check. We need to say, essentially, if the user guess is equal to the computer choice, then, and I don't need these parentheses, I don't know why I even did that. Now we will print this out. Great job, you did it. And if it does not equal that, then that means that the user still, or maybe it does equal, but it was on the 10th guess. I guess guesses would be less than or equal to because it's capped at 10. And then I'd say else here. We'll say print. You did not even guess my number in 10 guesses. Try harder next time. And let's go ahead and see what happens. So for example, I would just do 0 the whole time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so yeah, oops, needs to be less than 10. Yeah, I didn't even guess in 10 guesses. And then maybe what we would also want to do is output the let's see. You failed to guess. And then this will be the computer choice. Say, great job, you guessed. I'll even customize that. You guessed whatever. This will be computer choice and however many guesses. Failed to guess 10, or I'll say 10 was my number. No, you failed to guess whatever in 10 tries. Try harder next time. Awesome. Let's see what that does. Let's run that. Let's do 50. I'm too low. Let's do 70. Maybe I'll get a lucky one. 70 is too high. So that's already 2 guesses, so I'll get rid of some of them. So that's half of them. 1, 2, 3, 4, 5. I'll keep going. So now let's try. We'll just do 64. Too high. 3, 4, 5, 6, 7, 8, 9. So this is my last guess. So 64 is too high. Let's do 53. Failed to guess 55 in 10 tries. So their guess was 55. Awesome. Well, let's figure if we can do the last one just to make sure it works. So here, I'm going to cheat a little bit, and I'm actually going to print the computer choice right off the bat. Just cheat, straight up cheat. Let's see what happens. So the number is 85, so I'll do 70, 2, 3, 4, 5, 6, 7, 8, 9, 85. Great job, you guessed 85 in 10 guesses. So our logic works completely. I hope you have fun. I hope you had fun and you have fun with that. It is a neat little game if you just want to, get into some game development with Python. Creating text games like this is a very good way to get started. So that was practice problem 3. I hope you enjoyed trying to solve the problems that I've made for you. And in the future, they're actually going to be getting a little more practical and ramp up in difficulty because we are starting to get into some more complex concepts of Python and programming. The next practice problem isn't going to be for a while until after we get done talking about functions, modules, and file input and output. We'll see you guys in the next video of the Programming in Python 3 course.